Welcome to an extraordinary journey into the hidden world of ancient acoustic technology. 6,000 years ago, in underground chambers carved from solid rock, our ancestors may have discovered something modern science only formalized in the 1980s, sonochemistry. Today, we'll explore how the mysterious resonant chambers of Malta's Ħal Saflieni Hypogeum and other ancient sites worldwide weren't just ceremonial spaces, but sophisticated acoustic laboratories where sound transformed matter at the molecular level. This isn't just archaeology, it's a revolutionary understanding of prehistoric knowledge that challenges everything we thought we knew about ancient technological capabilities. Our story begins beneath the Mediterranean island of Malta, inside the Ħal Saflieni Hypogeum, a three-level underground temple complex carved from solid limestone around 4000 BCE. What makes this site extraordinary isn't just its age or complexity, but a remarkable acoustic property discovered by modern researchers. The temple's oracle chamber resonates perfectly at 110 Hz, creating powerful standing sound waves that visitors can physically feel moving through their bodies. This isn't random, the entire chamber functions as a precisely tuned acoustic instrument. When specific tones are produced here, sound doesn't simply echo, it amplifies and concentrates in ways that create physical sensations and measurable effects on materials placed within the space. The chamber's design suggests its creators understood principles of acoustic engineering that we typically associate with much later civilizations. To understand what might have happened in these ancient chambers, we need to grasp the basics of sonochemistry, a field that only emerged as a formal scientific discipline in the 1980s. Sonochemistry studies how ultrasonic vibrations can drive chemical reactions that wouldn't occur under normal conditions. When sound waves of specific frequencies travel through liquids, they create regions where the molecules are alternately compressed and stretched. This process, called acoustic cavitation, generates microscopic bubbles that grow and then violently collapse. These collapsing bubbles create extraordinary conditions, momentary hotspots reaching temperatures of 5,000 degrees Celsius and pressures exceeding 1,000 atmospheres. As Dr. Sherma Glickstein from the Institute for Archaeological Chemistry explains, these conditions can dramatically accelerate reactions or enable entirely new chemical pathways impossible under normal conditions. Compounds that wouldn't normally interact can be forced together at the molecular level. The physics behind this also involves acoustic streaming, where sound waves create directional flow patterns in liquids, concentrating particles and reactants in specific locations and further enhancing chemical interactions. Computer modeling of the hypogeum's acoustic properties has revealed something remarkable. Certain alcoves and niches would experience particularly intense acoustic effects, creating natural reaction vessels where sound energy could efficiently convert to chemical energy. Recent experiments at Oxford's Ancient Materials Laboratory have demonstrated that even modest sound levels, achievable with ancient instruments like drums, flutes, or human chanting, can produce measurable sonochemical effects when the acoustic environment is properly tuned. The key factor isn't volume but the sustained application of specific frequencies, suggesting that lengthy ceremonial activities would have been particularly effective at inducing chemical transformations. Evidence supporting this theory comes from residual analysis of ceramic vessels found in the hypogeum. These contain traces of ergot alkaloids, tryptamines, and harmala alkaloids that had undergone unusual transformations. While these compounds exist naturally in plants, the specific molecular configurations found in the residues show modifications that typically require catalysts or extreme conditions, exactly what sonochemical processes could provide. A 2019 study published in the Journal of Archaeological Science reports documented how vessels placed at specific acoustic nodes within megalithic chambers showed evidence of unique chemical reactions. When researchers replicated these conditions using reproductions of ancient vessels containing plant materials and water, exposure to sustained resonant frequencies produced compounds not present in control samples. As archaeochemist Paolo Vernetti notes, the vessels weren't just containers. They were reaction chambers, positioned precisely where sound waves would maximize cavitation effects. Microscopic examination has revealed another telling clue. The vessel surfaces showed distinctive erosion patterns consistent with prolonged exposure to acoustic cavitation. These micropitting formations differ significantly from standard wear patterns and closely resemble damage observed in modern sonochemical equipment. Particularly revealing was the discovery of crystalline deposits with unusual morphologies suggesting rapid formation under oscillating pressure conditions, precisely what would occur during sonochemical processing. Additionally, spectroscopic analysis of pigments used in nearby cave paintings has identified compounds difficult to synthesize without some form of energy input beyond simple mixing, potentially explaining the remarkable preservation of prehistoric artwork in specific acoustic environments. This Sonochemical hypothesis extends far beyond Malta. Similar acoustic properties have been documented in Newgrange Passage Tomb in Ireland, Chavin de Wantar in Peru, Hypogeum of Ħal Saflieni in Malta, Göbekli Tepe in Turkey, and the Luray Caverns in Virginia. What's striking is that many of these sites show evidence of liquid-based rituals and contain vessels positioned at acoustic nodes, precisely where sonochemical effects would be maximized. The geographic and temporal distribution of these acoustic chambers suggests independent discovery rather than cultural diffusion. Dr. Miriam Kolar, who pioneered acoustic archaeology at Chavin de Wantar, notes that the convergent evolution of these acoustic technologies across unconnected civilizations points to a universal recognition of sound's transformative properties. Her research team has documented how Chavin's elaborate system of underground channels creates predictable acoustic effects when water and air interact, essentially functioning as a hydraulic acoustic computer that could reliably produce specific frequencies during ceremonies. In southern India, the 7th-century Vitala temple features musical pillars carved from solid granite that produce distinct tones when struck. Dr. Annapurna Vishwanath has identified unusual mineral formations in ceremonial vessels typically placed near these pillars during lunar ceremonies, suggesting sound vibrations may have deliberately affected the contents of these vessels. While previous research focused on how these resonances might alter human consciousness through auditory stimulation, the sonochemical angle suggests more pragmatic applications. Ancient practitioners may have used these acoustic properties to create medicines with enhanced properties, extract plant compounds more efficiently, transform substances for pigments and dyes, and detoxify certain plant materials to make them safe for consumption. We're not suggesting they understood molecular chemistry, clarifies Dr. Glickstein. Rather, they discovered through generations of observation that certain sounds in certain spaces could transform substances in useful or spiritually significant ways. Ethnobotanical evidence supports this hypothesis. Many traditional plant preparations worldwide involve not just physical processing, but specific sounds, chants, whistles, or instrumental accompaniment, previously interpreted as purely spiritual elements. The sonochemical perspective suggests these acoustic components may have tangible effects on the extraction and transformation of bioactive compounds. Comparative analysis of traditional preparations made with and without accompanying sound elements has revealed measurable differences in chemical composition and efficacy. Particularly intriguing is the potential role of sonochemistry in ancient metallurgy. Specific acoustic environments could potentially accelerate oxidation processes or enhance the properties of metal alloys during cooling. Archaeometallurgist Dr. Hendrik Janssen has identified unusual microstructures in ceremonial bronze objects found near acoustic chambers that suggest sonic manipulation during fabrication, potentially explaining their distinctive patina and remarkable resistance to corrosion. This connection between sound and metal transformation might explain why so many ancient metallurgical practices included rhythmic hammering and specific musical accompaniments that were previously dismissed as purely ritualistic. The acoustic properties of the spaces where these activities took place may have been as important as the physical techniques employed, creating an integrated technological process embedded within ceremonial contexts. This archaeological discovery has sparked significant interest in the pharmaceutical industry. The specific frequencies and chamber geometries found in these ancient sites are now informing new approaches to green chemistry, where sound energy could replace environmentally harmful solvents and catalysts. Dr. Michio Aoyama, at Kyoto University's Department of Sustainable Chemistry, has developed what he calls archaeo-inspired sonochemical reactors that mimic the acoustic properties of megalithic chambers at a laboratory scale. These ancient temples may have accidentally discovered what we're now exploring deliberately: how to use mechanical energy rather than thermal energy or harsh chemicals to drive reactions, Aoyama explains. It's a beautiful connection between ancient wisdom and future sustainability. Pharmaceutical applications are particularly promising. Several compounds traditionally used in indigenous medicine become more bioavailable when processed sonochemically, suggesting that ancient acoustic preparation methods may have enhanced their efficacy. This insight has led to the development of new extraction techniques that preserve complex molecular structures that would be damaged by conventional heat or solvent-based methods. Beyond chemistry, these discoveries have profound implications for architectural acoustics and therapeutic applications of sound. The precise frequency relationships found in these ancient chambers are now informing the design of spaces for sound healing and acoustic therapy. Neuroscientist Dr. Elena Manoukian has documented how exposure to the specific resonant frequencies found in megalithic chambers affects brainwave patterns and certain inflammatory biomarkers, potentially explaining the reported healing properties that have been associated with these sacred spaces throughout history. This research suggests that ancient practitioners may have empirically discovered specific acoustic environments that produced measurable physiological effects, embedding this knowledge in architectural design rather than written texts. The therapeutic potential of these specific frequencies and acoustic environments is now being explored in clinical settings, creating an unexpected bridge between ancient ritual spaces and modern medical practice. Perhaps most fascinating is how this research fundamentally blurs the line between ritual and technology. What modern observers might dismiss as purely ceremonial or superstitious behavior may have incorporated a sophisticated, if intuitive, understanding of physical phenomena. We need to reconsider the false dichotomy between the spiritual and the practical in ancient societies, argues anthropologist Dr. Helena Mihailova. These sonochemical reactions would have seemed magical, transforming ordinary substances into something extraordinary through the power of sound and stone. The ritual wasn't separate from the technology but integrated aspects of the same process. This integration challenges fundamental assumptions about the historical development of science and technology. Rather than following a linear progression from superstition to empiricism, human technological development may have oscillated between intuitive and analytical approaches, with valuable knowledge sometimes embedded within ritual contexts that protected and transmitted information across generations without requiring theoretical understanding. The Sonochemical hypothesis offers a powerful example of how re-examining archaeological evidence through interdisciplinary lenses can reveal sophisticated knowledge systems previously hidden in plain sight. It suggests that ancient peoples were keen observers who developed effective technological solutions through multi-generational experimentation, embedding their discoveries within cultural and spiritual frameworks that ensured their preservation and transmission. This research is opening exciting new collaborations between archaeologists, chemists, acousticians, ethnobotanists, and engineers. By combining the analytical tools of modern science with a deeper respect for traditional knowledge systems, researchers are uncovering a more complex and nuanced understanding of prehistoric technological capabilities. As we unravel these ancient acoustic technologies, we're discovering that our ancestors weren't just listening to the stones. They were using them as sophisticated chemical laboratories, whispering secrets we're only beginning to understand. The discovery of sonochemical principles in ancient acoustic chambers revolutionizes our understanding of prehistoric knowledge. What we once dismissed as primitive ritual spaces now appear to be sophisticated technological environments where sound energy was harnessed to transform matter at the molecular level. From Malta's Hypogeum to Peru's Chavín de Huántar, these sites weren't just built to impress or worship. They were functional laboratories where generations of practitioners developed and refined acoustic technologies that modern science has only recently rediscovered. This convergence of ancient wisdom and cutting-edge research offers profound lessons about human ingenuity and the false boundaries we've drawn between science, spirituality, and cultural practice. As we continue to investigate these acoustic properties, we're not just learning about our past, we're uncovering principles that may help shape more sustainable approaches to chemistry, medicine, and therapeutic practices in our future. The stones have been whispering their secrets for millennia. We're finally learning how to listen. Thanks for watching. Please like, subscribe, and hit the bell icon for updates. Your feedback is appreciated. We hope to see you again.